All right, so we're going to go over the rational zero test. For the rational zero test, there are steps which I've noted here, and I'm going to put the example next to it just so we can kind of refer to it during this entire problem. Um, so let's see. For the example, find the real zeros of 2x to the third plus 3x squared minus 8x plus 3. Notice that it starts off with x to the third, so it's not quadratic. We can't factor by grouping because, spoiler alert, it doesn't work. The parentheses won't be the same. So instead, we're going to apply the rational zero test to solve for the x's. Um, the first step, make sure that the function is in standard form. The exponents are in descending order, so from greatest to smallest. So if you look, we've already got that part done. X to the third, x to the second, x to the first, and then no x at all. The next step is to find the possible rational zeros. These are the values that x could possibly be. Now keep in mind we should have three values of x total because our highest exponent or degree will tell us how many x's to expect. So for the possible rational zeros, excuse me, I'm going to find positive and negative P over Q, which is, again, as noted in the side, factors of constant over factors of the leading coefficient. So the factors of the constant is at the end, factors of 3. So the factors of 3 are 1 and 3 over factors of the leading coefficient. So the leading coefficient is in the front, coefficient is always in front of the x, so that's 1 and 2. So for the possible rational zeros, I'm going to divide each one of these numerators by each one of these denominators. So that would be positive and negative. 1 over 1 is 1. Positive and negative 3 over 1 is 3. Positive negative 1 over 2 is 1 half. And positive and negative 3 over 2, which is 3 halves. So these are my possible rational zeros. Now, from here, we're going to use what's called the remainder theorem, meaning out of these values, positive and negative, I'm going to plug one of these values into x and see which one gives me 0. There could be more than one. It could be the first value you choose. It could be the last value you choose. It doesn't matter. You just need one of them that would give you 0 because in the end, we're all going to end up with the same three values. So some of you are really good guessers and you always choose the right one, but we're just going to save some time here. And using the remainder theorem, I'm going to replace x with 1 to see if it gives me 0. So I'm going to take that same function, 2x to the third, and I'm going to replace the x with 1 plus 3x squared. I'm going to replace the x with 1 minus 8x plus 3. Remember PEMDAS? So 2 times 1 to the third is 1 plus 3 times 1 squared. 1 squared is 1 minus 8 plus 3. So I have 2 plus 3 minus 8 plus 3. From left to right, we have 2 plus 3, which is 5, 5 minus 8, which is negative 3, and negative 3 plus 3, which is 0. So I know that 1 works. So from there, what do I do with the 1? I apply synthetic division. So with synthetic division, you're going to put whatever x was equal to into the box, which was 1. And for synthetic division, you take all of the coefficients and you bring them down, making sure every exponent is there in consecutive order. Because let's say the x squared was missing, you would put a 0 x squared in its place. But I don't have that problem here, so I'm going to bring down every coefficient to 3, negative 8, 3. And the first step of synthetic division is to bring down the leading coefficient, which is 2. When this number hits below the line, multiply it by the number in the box. So 2 times 1 is 2. When the numbers are together, add them up. 3 plus 2 is 5. Number hits below the line, multiply it by the number in the box. Numbers are together, add them up. Negative 8 plus 5 is negative 3. And then number hits below the line, negative 3 times 1 is negative 3, which gives me 0, which shows me that my remainder theorem in step 2 was correct, or in the previous step was correct, because the last number always represents the remainder. So what does the rest of these numbers represent? So what this represents is the constant, and then each time you move to the left, you add another x. And here, x squared. So this is my function that I'm going to solve now using, again, any quadratic equation methods you learned in Algebra 2 via factoring, quadratic formula, completing the square. So I'm going to switch to the next slide. 2x squared plus 5x minus 3. So from here, I have 2x squared plus 5x minus 3 equals 0. You could use quadratic formula, you could factor. For me, I like factoring, so I'm going to take the first number times the last number, and I need two numbers that multiply to be negative 6 and add up to be the middle number, which is 5. So those two numbers are going to be negative 6, positive 6, and negative 1. Because if I add them up, I get 5, and if I multiply these two numbers, I get negative 6. Over each one of the two numbers, I always put the leading coefficient and x. And then from there, I put them as fractions because I may be able to reduce one. The first one I can reduce, so that gives me x over 3. The second one, I can't. I'm going to leave it alone. Each one of these fractions represents my parentheses. So the first one is x plus 3. The second one is 2x minus 1. Keep in mind that it equals to 0, so I'm going to bring that down. Anytime it's factored and the other side is 0, I'm going to just set my parentheses equal to 0, zero product property, and solve for x. So in the first one, I'll get x equals negative 3. In the second parentheses, I'll get x equals 1/2. And then I'm going to go back to the previous slide real quick. Now, there were supposed to be 3 values because the highest exponent or degree was 3. So I should have 3 x's. Where's the third one? The third one is always from the remainder theorem. I hope this helps, guys.